Good morning, everyone. So, in the last session, we started about the important implementation class called Treeset. So, Treeset basically what exactly it will do? It will try to provide the collection of objects in the ascending or descending order here. Okay. So, by default, it will provide in the ascending order. So, now we discuss about the constructors here. So, what are the different type of constructor we have? So, the particular constructor we discuss here. So, here you can see this is the tree set constructor. Internally, what we are doing is here we are trying to use the tree map because all the set related implementation classes internally, it is going to use the map related classes. Okay, map related classes. So now, whenever we are having okay, so whenever we are trying to create the respective implementation classes internally, we are trying to create the particular map object. So because we discuss about the hash map, hash set internally it is trying to create a hash map, and whereas a linked hash set also we discuss here, the linked hash set internally it is trying to create a hash map object because linked hash set internally it is extending from the hash set. So same way now we need to discuss about the tree set here. The tree set internally it is trying to use the important class called tree map. So now here you can see, so this is the class called Treeset, and internally it is extending from this particular abstract set here, and it is implementing the navigable set here. Internally, it is trying to implement this particular navigable set here. So navigable set is the interface. So how the structure we are having it, if you remember, so this is a collection, and collection internally it is extending from the set here. Set internally it is extending from the sorted set. Okay, and the last one is navigable set. Navigable set. So these are the hierarchy of the particular interfaces. This is the hierarchy we are having for the particular interfaces here. Now the navigable set is a sub interface because it is trying to extending the sorted set internally set internally collection. So navigable set is having specific methods. So we'll see what are the specific methods we are having under this particular navigable set here. Okay. Now observe carefully public class tree set, and this is an object we are having navigable map. So it is referring to the M. Now here, if you remember, the navigable map also internally it is using the key value pair. But here, whenever we are trying to work with this particular set related information, we'll provide only key. We'll provide only key. We are not going to provide any values here. So here you can see this is the key we are going to provide. Okay, this is the key we are going to provide, but value every time we are going to provide as a this is an object. Okay, it's the same similar to the hash set. So it's a similar to the hash set. So what we need to focus more about here, how the objects are it's going to be stored in the ascending order. Now, whenever I'm calling the public constructor, this is not the public constructor. It is a default constructor. Now this is a public constructor. This is the public constructor. Internally, we are calling this and by passing the tree map. So tree map internally, it is trying to convert into the navigable map. Okay. So this is very important. Treeset comparator. As of now, we did not discuss the comparator. We'll discuss later. So this is the one more constructor which is expecting the collection. So we already identified how the collection will work. So now the second one is sorted set. Okay, so these are the remaining methods we are having. Now observe carefully, we call the default constructor. So whenever we call the default constructor, it will try to create a tree map object. Internally, it will try to create a tree map object. So once it is created, now what I'm doing, I'm trying to call the add method. So this add method is coming from the where collection interface. This add method is coming from the where collection interface here. Okay, so what I'm doing here, I'm trying to give the 456. Okay, the second object integer dot add I'm providing. So 1 2 3 I'm providing, and integer dot add I'm providing. So something like 789 I'm giving, and after that we'll see the how the add method will work. But what I'm doing, so whether it is going to provide the natural order or not, so we need to check first. Add here. Okay, so around 4 objects are created. Now finally what I'm doing is I'm trying to print this particular integers. So we all know, so this is the add method we'll call to insert the values into the respective collection. So what is the collection we are using? So something like a tree set. Now, so whenever I'm calling, here you can see 1 2 3 1 5 9 4 5 6 7 8 10. But here you can see the order. So we did not provide the whatever the order we expected. But the order, if you remember here, we are getting as a natural order. Natural means so 0 to 9. So whatever the order we are having, the order we are getting. But if you remember, so we did not insert the value in the same way. First we are trying to inserting 4 5 6, and later we are trying to inserting 1 2 3. So 7 8 9 and 1 5 9. But how these records are inserting now? How these records are inserting now? So this is very important. We need to understand. So tree set implementation is little bit different compared to the asset and the linked asset implementation. So how this particular implementation it is going to be work. So to understand this, now what I'm doing is I'm putting a breakpoint. I'm running in the debug mode. Now, so here I'm trying to call the add method. So whenever I'm trying to call this add method, now here you can see, so it is calling the value of, so we will call the one more time. Now this is the add method, but M, what is the M here? If you remember, here we declare the M. Here we declare the M. So this is an M. But how this M object is created? If you remember, we call this is the default constructor. Whenever we are calling the default constructor, what we are doing is we are trying to create an object of this particular tree map here. Okay, we are trying to create an object of tree map here. So whenever we are trying to create an object of this particular tree map, so what is doing it? It is trying to initializing this dot M is equals to M. Now we observe the M, it is a tree map object. So what is the method we are calling? Put method. So what exactly the put method will do? It is trying to insert the record into this particular tree map. How it is going to insert it here? Here you can see the E. Okay, so the E coming from the where? Add method. What about this particular present? Every time the present will be the same. Every time the present will be the same. Basically, here the set related information, the set related interface related objects basically will work on only objects. Will work on only keys. Objects means so we'll work on only keys. But whenever we are trying to work with a hash map, so there we'll work with the key and value. So that we'll discuss later. Whenever we are working on the key, the value every time will keep as a present. So what is the present basically? The present here we created object. If you go a little bit up here, here you can see, so final object. Once object is created, it is not going to modify. This is called the final object here. This is called the final object here. Okay, the same final object we are passing. The same object, it is going to be passed to the multiple times. How many times we are going to call the add method? So for all the time, the present, the value we are going to keep as the same. The value we are going to keep as the same. Okay, so this is we can see here. So m dot put we are calling, and this is the key and this is the value. The key we are passing as a 456. The value every time will get as the same. So what is the object we are getting? Object at the rate 713. Okay, so here I'm trying to add here object at the rate 713. So this is the same object we'll try to pass here. Okay, so here you can see this is the key and this is the value. Now what I'm doing is root. What is the root here? Okay, what is the root here? So as of now, what exactly the root is doing? So this is very important here. Internally, we are using the entry. Internally, we are trying to use the entry. So what exactly this entry will do? What exactly this entry will do? Entry basically, if you go to the internal, here you can see key we are having, value we are having, and we are having left, we are having right, and here you can see we are having parent. So finally, what you understand? So if this is an object, so this object can contain the left, and the same this object can contain the right, and same this object can contain the parent. So this is the structure it is going to follow, and each and every object it will follow the key value. Each and every object it will follow the key value. Okay, so now, so this is the little bit different compared to this particular hash map here, because hash map internally it is using the node concept, node array, but the tree map it is not using the node, it is trying to use the entry. So entry is having left record, right record, parent record, and key value. Okay, so this is the structure we are going to follow for this particular tree map. Now we'll see how this particular entry it is going to be work. Okay, so we observe the entry. So this is the root. As of now, this root is null because this is the first record we are trying to insert. First record we are trying to insert here. So whenever we are trying to insert the first record, the t will be null. Now what we are doing is we are trying to call the compare. We're trying to call the compare. So now in our case, the t is null, compare. So what exactly the compare is doing? What exactly the compare is doing? So now if you remember, if the comparator is null, if the comparator is null, so which method we are calling it? We are calling the compare to method. The compare to is coming from the where? From the comparable. Okay, from the comparable here. So by default, the comparable implemented. Okay, by default, comparable is implemented, but comparator, it is not yet implemented. So to implement, we need to create a comparator object. So we'll create a comparator later. First, we'll focus on the comparable. First, we'll focus on the comparable. Here you can see the comparator is null. Here, the comparator is null. So whenever the comparator is null, we are calling on this particular comparable, and here we are calling the compare to. Here we are calling the compare to. So whenever we are calling this particular compare to, what we are passing here? So k1 dot compare to and k2. Okay. Now go to the compare to method. Okay. So we compared the particular objects here and we came here. Now what exactly we are doing now? After comparison, what we are doing here? We are trying to create entry record. So this is very important here. How we are trying to create an entry record. Okay, how we are trying to create a entry record. Here we are calling the constructor by passing the three parameters. The first one is key, second one is value, and the third one is parent. Third one is parent. Now here the parent, as of now, this is the first record we are going to have as a null. We are going to have as a null here. Now whenever we are having this particular entry, now what happened here? This is the root we are initializing. Now here you can see key value we are getting, but the parent is null, left side is null, and right side also null because of this particular first record. Now if you remember, here, so we are checking the mod count and we are returning null. We are returning null here. So we are coming here. If the map dot put, if it is equals to null, so simply it will try to return as a true. Simply it will try to return as a true. So what we observe so far? What we observe here? Now internally the tree map it is trying to use the entry. Internally it is trying to use the entry. The entry it is going to have a key value as well as parent. Key value as well as parent here. So this is what we need to understand here. Now the second record. So first record we inserted 456 as a root. Now the second record I am trying to insert now. The second record is a 123. How this 123, how this particular 123 it is going to inserted here. So if you remember the root it is not a null. The root it is not a null here because the first record we inserted. We are coming here. The comparator. The comparator is, as of now, it is null. So I will let you know when we can go for this particular comparator. But as of now, the comparator is null. Okay. So this is false. Now here we need to understand here. If the key is null, we will try to throw the null pointer exception. But in our case, key is not a null. So finally, what we are doing is, whatever the key we are getting, I am trying to convert into this particular comparable object. I'm trying to convert into this particular comparable, and the k we are going to get. So this is the k. It is trying to refer to the comparable. It is trying to refer to the comparable object here. Okay. So what exactly we are going to do here? So whatever the t basically it is the root here. If you go to the top here, the root, whatever the root we are having, I am trying to initializing into this particular t variable. The t, again now we are initializing into this particular parent. Again, we are trying to initialize into this particular parent. So now if you remember, k dot compare to k. So what is the k? The k we are having 1, 2, 3 and t dot k. What is the t? T is the root. Root dot key. What is the value we are having? So if you remember, the current k is having 1, 2, 3. Okay. And t dot key. T dot key we are having 4, 5, 6. T dot key we are having 4, 5, 6. So whenever we are having this particular 4, 5, 6, so what exactly it will do? We are calling the compare to method. Now observe carefully what exactly the compare to method will do now. What exactly the compare to method will do now. So now go to this particular compare to. It is calling the integer class. Inside the integer class we are having compare to. Now, so here you can see this is the compare to method. Okay, this is the compare to method. We are going to call this dot value and another integer dot value. So the this dot value, what we are going to pass here, this is something like 1, 2, 3 and another integer something like 4, 5, 6. So here what exactly we are doing is, this is the logic. Okay, now here you can see the logic. Here you can see the logic. What we are doing is int x. What is the x we are having? 1, 2, 3. Okay, x is equals to 1, 2, 3 and y is equals to 4, 5, 6. Y is equals to 4, 5, 6. So here what we are doing here? So we are doing here x less than y. X, so how much we are having? 1, 2, 3 less than y 4, 5, 6. 4, 5, 6. So it is trying to return as a true here because 1, 2, 3 is a small value, 4, 5, 6 is a bigger value. Okay, it will get as a true here. Whenever we'll get as a true, what happens internally? We'll get the -1. Okay, we'll get the -1 here. So whenever we are getting -1, whenever we are getting the -1, so what exactly the compare to method will do now? What exactly the compare to method will do? So now coming out of this, so we observe the, we'll get as a -1. Now here, so what is the comparator we are getting? Now here you can see the comparator value -1. Okay, so just now we observe the, we'll get as a -1. Now whenever we are getting -1, here you can see if the comparator less than 0, if the comparator less than 0, what we can understand here? What we can understand here? T dot left. T dot left. So what is the T dot left? As of now, T dot, T is the root. We don't have a left because T only we inserted as a root record. The root record does not contain the left, right and parent. Left to right and parent. So what we are doing is, even though if it is not available, but still we are loading T dot left here. T dot left. So if you see, we'll get as a null. We'll get as a null here. Now whenever we are getting a null, what we are doing here? So this is a T. Okay, this is the T, and here if you remember, while loop we are having. So this piece of code we implemented under the do while loop. Whenever the while loop is not, like if it is trying to return as a true, it will repeat one more time. But in our case, one time we executed, we are checking the condition, but the t value it is null, the condition will become false. We are coming out of this particular do while. We are coming out of this particular do while. Okay. So what we are doing next? What exactly we are doing next here? So if you remember here we are trying to create entry record. Here we are trying to create entry record here, but the entry record we are passing a parent. Getting the point? Earlier the 456 we don't have a parent because the 456 we are making as a parent. But whenever we are trying to work with this particular 123, for the 123 we are having 456 as a parent. 123 456 as a parent here. So finally we created the entry record. Now here, so what we are doing, again we are checking the condition. So comparator less than 0. So comparator less than 0, parent dot left. What is the parent? Parent we are having 456 and left. What is the value we are initializing? Whatever the entry we created. Whatever the entry we created. If you observe carefully, so this is the parent. This is the parent. The key we are having 456. Okay. The value we are having present. The value we are having present. But for this particular record, we are having left. We are having left. The left record we are trying to providing 1, 2, 3 and same value present. Okay. So now you can see, whenever we are having bigger value, so as of now we are making the parent, and whenever we are going to have a small values, so that will keep as a left side. That will keep as a left side here. So now you can see parent dot left, so that we are trying to initializing as a e. The e, so just now we created. Now after this, what we are doing it? So what exactly this fix method will do now? Fix after insertion. Now you can see color is red we are making. Color we are making as a red, and x not equals to null, and x not equals to root, and x color if it is red here. So this loop will repeat. And what we are doing is we are trying to make as a color block here. So simply we are coming out of this. Now we are increasing the size and more count, and we are returning null. Finally, what you understand? Finally, what you understand here? Here you need to understand the important concept to call the for the first record. For the first record, this is the condition will satisfy. Okay. For the second record, if you provide the comparator, it will satisfy this particular if condition. Otherwise, it will go to this particular do while block. What we are doing a do while block? Simply we are calling the comparable compare to method. After calling this particular comparable, based on the positive or negative value. Okay. So based on the positive or negative value, if the comparable will get the -1, it will do this. Otherwise, if you get the positive, it will go to the right side. So finally, what you understand here, based on the comparative, if it is a positive value, we are setting into the right side. If it is a negative value, we are setting into the left side. Okay. For the root record, we are setting this particular values. So now we observe the one root record and one left side record. So now we'll go to the second record. Sorry, third record, 789. Now same will do the 789 also. It will call the comparator. Now go to the put method. So root it is not a null. Okay, comparator is also null. Now key it is not a null. So we are doing the comparable. Now whenever we are doing the comparable, what is the value we are getting? Now here we can identify the compare. What is the root basically? Okay, what is the root we are having currently? The root we are having 456. Still the 456 we are making as a root here. Okay, now observe carefully here. Compare to we are calling. So this is the compare to. Now here you can see x value 789, y value 456. So carefully observe here. X 789. So less than 456. It is trying to return as a false here because 789 value is the bigger value compared to the 456. Whenever it is false, now this is the code it is going to execute. This is the code execute. And here x and y value both are not same. X and y value both are not same. So finally what we will do, simply we'll try to return as a positive value. Earlier we got a -1, but currently we are getting as a positive value. Positive value we are going to get here. So now, so we observe this particular compare to, we are getting as a positive value. So this particular condition will not satisfy. Okay, so this particular condition will satisfy. So now you can see what we are doing is t dot right. What is the t? T is the root. So t value we are having as a 456. T dot right. As of now, we did not insert it. T dot left we have, but t dot right we don't have here. Okay, so we'll get the 0. We'll get the 0. We're coming out of this. Now we are creating an entry with what is the key we are providing? 789. And what is the parent? Parent we are having 456. Okay, so after that, now parent dot right. What is the parent? 456 dot right. Now we are trying to initializing the right value as a e, newly created e. So the diagram it is going to be look like this. How it is going to be look like here? This is the root. Okay, and the left side we are having 1 2 3, and the right side we are having 789. So this is the records are now inserted. Now these records are inserted. So we'll go to the last record. We'll go to the last record. How this record is going to be inserted now. Let me call this particular record. This is calling as a 159, and now here you can see root. Root is not in null, and comparator is also not in null. Sorry, comparator is null, and key value we are checking. Key value we provided value, so it is not in null. Now finally comparable. So we are calling the compare to. Whenever we are calling the compare to, so what is the value we are passing? So if you can see 159, x value 159, and y value we are having 456. It is a bigger value. It is a bigger value, so it will satisfy. So this will become true. This will become true. Whenever it is become true, what happens basically here? What happens here? So simply, okay, so simply will return as a -1. Simply will return as a -1 here. Okay, so whenever I'm trying to return as a -1, we observe this is the condition will satisfy. Whenever it is satisfied here, now we are loading t dot left. So t dot left to what is the value it is going to be loaded? So the load value it is something like 1 2 3. T dot left we are having because t is a 456. T dot left we are having 1 2 3. We are going to load as a 1 2 3, and here this particular 1 2 3. Now we are going to load now. We are going to make as a root record here. We are going to make as a root record 1 2 3 here. So now here you can see whenever we are making the root now is going to change as a 456. So one more time it is going to be repeated. Again we are calling the compare to. So earlier the root we made as a 456, but currently the root record is 1 2 3. Okay, so 1 2 3 less than 1 5. What is the value we are having? 159. So still it is going to have as a condition will become true. So we'll get as a -1. We'll get as a -1 here. So whenever we are getting as a -1, what we can understand here? What we can understand here? So now we'll see the how these particular objects are going to create it. So compare to x. Okay, so sorry, it's a reverse. X we are having 159. X we are having 159, and the root y we are having 1 2 3, and the root we are having 1 2 3. So this will become false here. So we'll get as a positive value. We'll get as a positive value. So whenever we are going to get as a positive value, what we are doing basically, here, so it is trying to check as a right. For the positive values, it is going to check as a right. Now here you can see t dot right. What is the t? T is a 1, 2, 3. For the root 1, 2, 3, we don't have a right record. So it will become a null. We are coming out of this. Okay, we are creating a record, but the parent now change. What is the parent? 1, 2, 3. Okay, parent now change. So if you remember, so whenever the parent is changed here, so parent dot right is equals to e. Okay, so the structure, how it is looking now. The structure, if you remember, so this is a 4, 5, 6, 4, 5, 6. Right, we are having 7, 8, 9, and left we are having 1, 2, 3. Okay, left we are having 1, 2, 3. But for this particular 1, 2, 3, left we don't have. Simply we can make as a null. But the right we are having 1, 5, 9. But the right we are having 1, 5, 9. So this is very important. We need to understand here. So this is the structure it is going to be followed to insert the record into tree map. Okay. So whenever we are providing it, so which method is going to play as an important role here? So this is the method. The comparative method will play as a very important role. So to provide the whether the record it should be inserted into the left side or the whether the record it should be inserted into the right side. The comparative method will play as an important role here. Okay. So this is we observe. Now here the comparative is coming from the where comparable. So comparable basically whenever we are trying to work with a predefined data types. For example, so we observe integer. Integer, it is trying to implement the comparable. So go to the string class. Okay, go to the string class. So where we define the, yeah, here also, yeah. So go to the string class. Now here you can see comparable. So most of the predefined classes, okay, most of the predefined classes are implemented comparable, and the comparative method also internally implemented. So now we observe the by default it will work on the comparable to insert as a record in the natural order like ascending order. Okay, so now I want to go to the descending order. Getting the point? Now I want to go to this particular descending order. So how we can go for this particular descending order? So by default there is no concept here, but if we want to go to this particular descending order, what we can do here, we can do the customization. So how we can do the customization? Here we are having person class. Okay, here we are having person class. So now you can implement the comparable. Now you can implement the comparable. So what we can provide basically, we can provide the person. Okay, so here I am trying to provide the comparable. Now you can override the method called compare to. Okay, override the method called compare to. So what I will do, whatever the logic we observe, if you go to this particular integer class, if you go to this particular integer class, so here you can see the logic. This is the logic we are using. Okay, now here, what is the x and y? So here the x I'm going to make as a x in place of x o dot. We'll work on the ID. We'll work with the ID basis. We'll work with the ID basis. So here, what I will do, I will go for this particular one. Whenever the big value we are going to get as a, we'll make as a 1, and if the o dot ID, and here now I'm trying to make as a -1. So this is the okay. So this is the particular the comparative method we implemented here. Now what I will do here, I'm going to create a one more object. Here I'm going to make as a one more object. So this is something like a tree set person I'm making. We'll go for the tree set. So simply tree set object. Tree set dot add method. But here, so I'm going to create a person object. ID. So ID I'm going to give as a 789, or we can go for the different value. 421 I'm giving, and name Treeset 1, and what is the last value? Email. Add the email. The email, so tree1 dot treeset. Okay, treeset.com. So this is the first record. Okay, I'm planning to insert the around of 4 records. So these are the 4 records I inserted. Now put a breakpoint here. Okay, put a breakpoint here. So here we can run the method. Okay, so when we want to do the customization, what we can do basically, so we need to create the respective class, and we need to implement the comparable or comparator. We can override the method, and we can add a logic here. So currently we are implementing the comparable, and we are trying to work with a comparative method. So now you can see comparative we are getting a o.id. So what is the o.id? 421. Okay, 421. So this is also 421. So it will become 0. Now I'm adding. So after adding, I'm not printing. Okay, let's me print this records. Sysout Treeset. Whenever I'm trying to print this. Now here you can see okay, true string we did not implement it. Let me implement the toString. Okay, so this is the toString I implemented. Now again I'm going to be run. So now you can see only one object is inserted. So only why the one object is inserted? Because of this. Okay, so here this dot id. Okay, so every time we are kept checking with the current object. So because of that, it is overriding here. Now run the same example. So here you can see the descending order we are getting 421 and 365. After that 258 and the last record something like 147. So this is the way the records we can do the reverse order. But how we are doing the reverse order? To do the reverse order, what we did, we created the class and we implemented the same comparative method but we provided the comparative logic is different. Comparative logic is different here. So this is very important, we need to understand. By default, it is working on the natural order, like natural in the sense, so 0 to 10. So it is doing this particular operation. Whenever we are doing whenever we are trying to implementing the comparative method, we can do both here. Both we can do. So either we can do the descending, or we can go for this particular ascending also. But ascending already it is implemented. So for the descending, we can override the comparative and we can add the specific condition. So this is we can do with the help of this particular comparability. Okay. So if you're not interested, what we can do, remove this particular name and email. Okay. So name and email. So that we'll get only IDs related. Now again, I'm going to be run the same example. You'll get IDs. You can easily understand. So ID 421, ID 365, ID 258, and 147. Okay. So this is we can identify. Now if we want to go to the ascending, what we can do? What we can do? Change the logic here. This logic you need to change. Okay. This logic. So simply make a -1, and here you can make as a +1. Here you can add as a +1. So now if I'm going to run the same example, it will come as a reverse here. So 147, 258, 365, and 421. So this is coming as a natural order. So same how we got as a this 1 2 3 1 4 9 sorry 159 and 4 5 6 7 8. Same way we are getting. So finally, what do we understand here? So when we are trying to work with this particular tree set, so tree set internally it is going to use the two important concepts. First one is comparator, second one is comparable. The comparator, what it will do, we can implement the specific method called compare, and you can add a specific logic. So as of now, we did not discuss the comparator, but we discussed the second approach called comparable. So what exactly the comparable is doing? The comparable, now we have a method called compare to. So based on the compare to method, we are making the object as a natural order. So like it is a ascending order. Okay. So now we'll work on the comparator. Now we'll work on the comparator. So here, what I'm doing here, this method I'm trying to remove now. This method I'm trying to remove. Now, one more important way, instead of this particular comparable, comparator. Okay. So here I'm trying to work with this particular comparator. Earlier, what we did, we provided the comparable. Now I'm trying to work with the compare. Now I'm trying to work with the compare. Okay. So this is the comparator we are using. So earlier we used the method called compare to, but currently we are using the compare. How we are comparing a person object 1, person object 2. Person object 1 and person object. So here this method is expecting two parameters. This method is expecting the two parameters. So we can work with two parameters. Let's say here 01 dot. Okay, it is not a 0, it is O1 dot. It is a O1 dot ID less than O2 dot ID. Okay. If this particular O1 dot ID less than to O2 dot ID, what I will do? What I will do? Simply I will go for the question mark, and here I will make as a -1. I will make as a -1, and here so same O1 dot ID equals to O2 dot ID. O2 dot ID. So whenever it will satisfy here, what I will do after the question mark, I will make as a 0, otherwise +1, otherwise +1. So this is, we can work on this particular simple example. So currently what I'm doing is, I'm checking the both object. So using this, now I'm going to work with based on the ID, based on the ID natural order. Now here, so this is the tree set. Now what I will do, here I'm going to pass as a, here I'm going to pass as a comparator we need to pass. So what is the comparator we are going to pass now? Okay, what is the comparator we are passing? So here the comparator we need to create explicitly. So whatever we did here, so this is the person class. Now person ID, person ID comparator implements comparator. So I'm making the person. Okay, so this is we can do, and here we can remove this piece of code because so specifically we are implementing here. Here we can remove this, save this, and override the method here. Okay, get ID. ID is a private variable. Okay, this is we can do. Now person ID comparator. So same what we can do, we can create a one more comparator. Person name comparator, name comparator. It will implement the same comparator. It will implement the same comparator. The generic type we are making as a person, and here I'm going to override the method called compare method. So here what we will do, here we can work on the o dot get name. Okay, get name less than o2 dot get name. Okay, so if it is false, we'll do the -1, and after the question mark, after the colon, we can do the two logic here. What is the logic we can do? O1 dot get name. Okay, but here the get name basically it is a string here. We are trying to converting into the int here. What we can do? So what we can do basically here the string related compared to how it is implemented. String related compared to how it is implemented, we need to work here. If you go to this particular string class, here we can identify the compared to. Okay, here we can identify the compared to. So where we are having, this is the logic. This is the logic we are having. So these are the same logic we can implement here. These are the same logic here. So now you can see we are calling the compare to v1 and to v2. What is the v1? Current object, and v2 another string dot value. Another string dot value. Okay, so here, so same logic also we can implement whenever we are trying to work with the name parameters here. So to identify here, I can check this. Simply, I can add this. Simply, so here I can add this. Okay, let's see. We cannot work on this. Okay, maybe it is a private method. Okay, This is the private method and this is the final class. Oh, it is not a public class, so we cannot use this. Okay, this logic we cannot implement here because these particular classes are not having a public here. Now, what we will do, we'll go to internally what is the logic is implemented. Okay, what is the logic it is implemented. So here you can see, so we are calling value dot length, another value dot length, and this is the compare to method. This is we can do. Okay, so this is we can do. Now here byte value and this is a byte another. Based on this particular byte, we are calling the get char and get char. So we are doing this is the logic here. This is the logic we can do here. To read this particular logic, what I will do, okay, length 1 and length 2. So to work on the length 1 and length 2, what we can do basically, one dot get name and here get bytes dot length. So this is we can do, and the same way, okay, instead of doing this, we can work here only directly. Okay, so this is the first object here, get name dot get bytes. So byte 1 and byte 2. And here byte 1 dot length. So minimum and maximum we are getting and value. So what is the value? In place of the value, we can pass as a bytes here. And another one bytes here. So here the value, what is the value we can take here? Value means bytes here. And here bytes 1. So get char. Okay, get char. So what is exactly the get char method will do now? Okay, go to here, find out the get char, which is coming from the where, which is coming from the where. So this is the public method. Okay, so this is the public method we are having. Java.base string latin.java. Okay, this we cannot use the because the class itself we are not able to use here. Okay, now what I will do here, I'm going to implement the method. Here I'm going to implement the method. So finally, so one thing we need to understand here. Okay, so length 1 and length 2. Length minus 1 and length minus 2. Now here, what is the length 1? The length 1 we are having length 1 and length 2. So same we can provide here also. Okay, so this is the logic. So this is something like a person name comparator. Now the first one, person ID comparator. These are the two IDs we can like comparator object we created. Now go to this particular tree set. Now go to the tree set here. So here what I'm doing here, person ID comparator. Here I'm passing the person ID. These subjects are going to be compared based on this particular ID. Okay, based on this particular ID is compared. Now I'm going to change to the person name comparator. Okay, now I'm going to change to the person name. But here, Okay, so whenever I'm trying to pass the person name comparator, we want to work with the name here. Okay, so name to work here, what we can do? So tree set 1, tree set 1 to I'm giving, and 21 I'm giving, 51 I'm giving, and 81. So these are the names. Okay, these are the names I've changed here. So now I'm going to be run. Now I'm going to be run. If you see 1, 2, so 21, 51, and 81. Based on the name, we are getting as a ascending order. But here you can see the IDs. IDs will be different here. ID we are getting as a 451, so 365, okay, and 258, and finally 147. So IDs are in the reverse order, but we are working on the name here. Whenever we are trying to work with the name, so the names will make as ascending order. So this is the lowest like ascending, and this is the highest. Okay, to change this, what we can do, we'll go for the ABC. So you can easily understand ABC XYZ and MNO, and here DEF. Okay, so now you will understand the how the based on the name the sorting is working. So ABC we are getting, second DEF, third MNO, and last XYZ. Last XYZ. So you can see the last record we provide as a DEF. But whenever we are doing the printing, we are getting as XYZ. Now what you understand here, it is doing the sorting behavior. How it is doing the sorting behavior? Same, the root element, left side record, right side record. But how this left to right and root records are identified based on the compare, based on the compare. If you go to here, whatever this particular the compare, like this is compare name, like a person name comparator, whatever you provided, this is the logic it is going to be executed. This is the logic it is going to be executed. So now here what I'm doing, I'm going to be run in the debug mode. I'm going to run in the debug mode. Now here you can see, okay, so this is the constructor we are calling. We are setting this particular constructor. Now I'm going to be call as add method. So this is the add method. Okay, this is the put method. Root. What is the root? First record we are inserting. It is null here. Okay, so this is a null. We are calling the compare. From where we are calling it? If you see here, from here internally it is calling the comparator. Compare. So, but you can see person name comparator. Whatever the comparator we created, the specific class it is calling internally. Okay, the specific class internally it is calling. So it is executing the all the bytes here. All the bytes it is executing is coming out of this. So compare we are calling. After comparing, we are creating a root and we are calling the return null. So second record. Second record. Now, so if you understand here, now root is not a null. We are coming out. If you see the comparator, earlier we got a null, but currently we are not getting the null because we created the object. What is the object we created? Person name comparator. We created the person name comparator. So whenever we are having person name comparator, CPR not equals to null. Whenever CPR not equals to null, this is the logic. Here also we are having the same do while only. Okay, but this logic is executing based on this particular comparator, and this logic is executing based on the comparable. Okay, so this is only the main differences we can understand. Using the comparator, what is the main advantage we are getting here? So we created the two classes. This class is working on the based on the ID, and this class is working based on the name. Based on the name. So what about this particular comparable? Comparable every time it will work on the current object. So there is no scope to work with the multiple classes. But the comparator we are going to have, we can work with the multiple classes. So this is we can do with help of this particular comparator. This is only the main difference here. Okay. So any questions regarding this particular tree set, how it is implementing internally with help of the comparable as well as comparator? So anyone having any questions? Yeah, comparator basically it will give you the more advantage compared to the comparable, because in the real-time application sorting we are going to work with the different fields here. So whenever we are trying to work with the different fields, so that we cannot achieve with the comparable. So we need to use the comparator. So how I created person name comparator, ID comparator. So you can go for the email comparator, you can go for the salary comparator. So you can work with the different comparator. So whenever we are trying to make the sorting, the sorting logic will work on the this particular class and it will execute it. Okay. So still any questions? Okay, it's a simple comparator. So compare method. You can see the compare. What we are doing here. Here we are having ID. It's a simple understanding ID less than ID, because it is a integer numbers. Just simply we can check with a less than or greater than. But whenever we are trying to work with a name, name is a string here. So whenever we are having a string, what we are doing here, each character we are checking. Okay, we are converting into the byte. Byte what it will do basically. So even though we work with a string, it will convert it into the integer number, and we are checking the length here. So minimum length. Okay, minimum length why I'm checking, because this loop will repeat until the minimum length is going to be satisfied. Okay, so math.minimum we are calling by providing the two values. So based on this particular length, this loop will repeat. And here, if you remember, it is an array. Here it is a array we are checking. So byte array. Okay, byte array will contain the integer number. So what exactly we are doing here? We are checking the each and every number. If it is a not equals, we are checking the get char. Get char means the based on the number we are trying to convert into the character. Okay, whatever the number we are going to get here, the number it will try to convert automatically into the character. So the character we are doing the here, the particular index. So based on this particular index we are loading, and we are doing the subtraction but the particular cutting character. So whatever the number, let's say, so here let me show you the annotation. Here, so A character, how much we are going to get? 65. Here we are having character B. So character B, 66 here. Whenever I'm doing I'm going to get as a minus 1. I'm going to get as a minus 1 here. Okay. So whenever we are doing this. So same way, so you can see the Z. So Z basically 96 maybe, 96 or 95. And we can do the Y. Okay. So this is the ASCII value of capital A, and this is the ASCII value of this particular capital B. So Z mostly 96, I guess. So Y 95 here. Okay. So this is we can identify. So the same way it will load the particular character, and we are doing the subtraction. Whatever the value we are going to get, whether it is a positive value or negative value. Now based on that, the comparator, what it will do, it will try to insert into the left side, or it will try to insert into the right side here. But finally, what we are doing here, because of this particular string, we are loading all the bytes here, and we are doing the minimum length. Once we get the minimum length, we are repeating one by one up to satisfy the minimum length here, and do each and every character we are loading, and we are doing the subtraction. So this is this particular name related logic we implemented. So because of the string only, we implemented this much logic. And if it is a number related, simply we can use the ID comparator. Okay, so to understand this particular name comparator, first what you need to understand is how the get bytes will do. How this particular get bytes. So here you can see, so string coding encode. Here we are having the coder and we are passing the value. The value basically we are trying to initializing as a byte only. If you remember in the earlier example we already discussed here, the string class internally it is going to be stored the value under the byte array. The same byte array we are loading now. So it is basically where we are having Treeset. No? Let me go to the particular class name comparator, right? So basically this is a bitwise operator. It will do the conversion. Basically here what I'm doing here I'm trying to load the integer value. So based on this particular integer value, the bitwise operator will convert into this particular character. Okay, so just review the earlier existing recorded sessions here. So I already have given in the WhatsApp groups, so you can understand what exactly the string class will do. So where you got this particular here I cannot share. So just message me in the WhatsApp. I can share.